So the multicasting will make the number of packets that will be flooded minimum. Meaning, if I do unicast to 10 people, I need to send 10 copies of same traffic because I'm doing unicast. I'm sending an information to 10 different people. Same information to 10 different people. When I put 10 different people IP address, then it becomes 10 duplication. 10 times the packet will be duplicated. Instead of sending to 10 different destinations, if you can send it to a group where those 10 people are already grouped. For that, we need an IP address. We group all those 10 people with an ID, with the layer 3 address, with a 32-bit address, with a class E address, so that whenever you send some traffic to that address, all those 10 will receive it. So you don't need to send now 10 copy of same packet. You just send one copy to that multicast address, based on which all 10 will be receiving it, based on which all 10 can receive the update. For example, if this is sending a layer 2 broadcast, if this server sends a layer 2 broadcast, if this sends a layer 2 broadcast, that should not be sent to all the leaf. It needs to be, it should go only to those leaves where the receivers may be connected. Let's say this is VLAN 100, this is also VLAN 100. I got another device here that is also VLAN 100. So if I need to send an ARP request, I should send only to this leaf and this leaf, because there are devices connected only to these leaves which belong to 100. This has got no VLAN 100 member. How do you avoid that? We group these devices with a common multicast address. And when I send an update to that multicast address, only these two will receive. Again, let me tell you, I'm not going to send 2 copies. I'm just going to send 1 copy. Only 1 copy I send. Only 1 destination IP address. And it may go via both the path, but it is only 1 destination IP address. So in this link, I'm not going to send 2 copy, only 1 copy. And when it reaches the spine knows the multicast group members, or leaf 3 and leaf 4, so they will forward it to leaf 3 and leaf 4. The spine will forward it. So multicast helps us to reduce the number of packets. See, if there is no multicast, what would have been done, if you want to send a copy, if you want to send the ARP request to this leaf and this leaf, then you need to put the VTAP address of this and this, send the 2 packet in this, send the same copy of 2 packet in this, and this will receive it, and it will send 1 copy to this one and 1 copy to this one that belong to this one, and this will also send the copy belong to 3 here and send the copy belong to here. But we are using more bandwidths, double the amount of bandwidth, to avoid duplication of packet and more bandwidth utilization. We depend on multicasting. So even here in VXLAN, if you use multicasting, it will reduce the amount of flooded packets. So for unknown unicast, broadcast and multicast, for broadcast and unknown unicast and multicast, usually they used to say BUM, not UBM. Anyway, unknown unicast, broadcast and multicast are broadcast. And for this, you need to flood it. But flooding with many duplication can be avoided by multicasting. So instead of sending the flooded packet as a unicast or sending the flooded packet as a broadcast, if I send broadcast, it will go even to leaf 2. That's not correct. There is no need for forwarding the packet to leaf 2 because in leaf 2 we don't have anyone to receive there. So using multicast is what the best idea. For multicast, we need a rendezvous point, RP. Have you heard about this earlier?
No.
Okay. What is rendezvous point? That's the middle device which will know the sender as well as the receiver. Here the sender is, in our example, leaf 1. The receivers are the group, leaf 3 and leaf 4. So who knows that? Only the RP will know it. How they know? The group members will go and tell RP, I want any traffic that is coming from that particular multicast address. Now when the packet to the multicast address comes, the RP only will say, okay, I have a receiver for you, you go this way. So we need to configure all the spine as an RP so that it can be a bridge between the sender and the receiver of the multicast traffic. This rendezvous point is what we call as RP. Rendezvous point.
What is spelling?
No. The spelling will be a little bit tricky because it's not an English word. Rendezvous point. Rendezvous simply means gathering point in English. Gathering point. So as the word says rendezvous, the gathering point, the meeting point, both the group member and the source of the multicast, we used to say S, G, source, group. They come and meet the RP, and the RP will help the group member to identify the source and source to identify the group. That's how the packets can get distributed. So when you learn multicasting as a separate topic, it will be more interesting for you. This is an interesting topic to an extent I have explained to you that we need an RP. So we need one RP, but we have more spines. Then how can you have one RP? That is where we do anycast RP. What is anycast RP? For both the RPs, we'll give the same IP address. For both the RPs, we'll give the same IP address, so that when leaf send an update to the address, to the RP's address, it will be received by both the RPs, and both the RPs will maintain a copy of S, G, source, group member. That is good for availability. All the spine will be available for multicast distribution. Even the multicast packet will be getting distributed using equal cost multipathing, both the paths. So in our topology also, we are going to configure these two as anycast RP. Kindly focus here. We are going to use another address. This is 6, no? We are using this address already as what? VTAP address. virtual tunnel endpoint address, correct? So you should not be using the same address now. So we are going to create one address on both the spine. I think it is .100 in this. .100 192.168.0.100. So on both the device we are going to have 192.168.0.100 address. Have you done VRRP?
VRP, yes, I remember.
Yep. In VRRP we have a floating IP address and floating MAC address, correct?
Yes.
Virtual IP address, correct? That's how they used to call it, virtual IP address. Even HSRP you will see that. Similar to that, this Anycast RP is going to work. This will be the address given in common for both the RPs. And also we'll give a MAC address, you see. No. Okay, it's okay. We are using only the IP address. Okay, in common. See, on both 6 and 7. 6 and 7 are who? 6 is spine 1, right? 7 is spine 2. Now both are going to use this one address as an Anycast RP address, so that both can be an RP. So let me walk you through this configuration. See, we are creating another loopback interface called .100, and then we are including that interface in OSPF. When you do that, now the .100 will be advertised from spine 1 as well as from spine 2.
Spine 2.
So when both the spines are seen with the same network and with equal cost, definitely it is equal cost. If this is 10 gig, this is also 10 gig, so equal cost. When the multicast address is sent to RP address, it will go both spines at the same time. So that's the configuration. Now what is this called? PIM spats mode. See, this PIM stands for Protocol Independent Multicast. PIM, Protocol Independent Multicast. We need to run PIM on all these fabric links. We need to run PIM on all the wires that is connecting this leaf and spine. Only then the multicast packet can be transported. PIM is necessary. Without PIM, the multicast packet will not know on which link to pass through. PIM should be enabled for the multicast to work on the link, for the multicast packet to be transported over the link. So we will be enabling PIM spats mode on all this physical wire as well as the two loopback interface that we have. Already we have loopback 0 with 0.6 and 0.7 and 0.8, 0.9, 0.10 and 0.11 on all the leaves. We should run PIM on physical and logical interface. Plus the new interface that we add now, the loopback 1 interface with 0.100, that also need to be part of PIM. And what is the spats mode means? See, we have two different type of mode in PIM in multicasting. One is called dense mode. This dense mode no one uses now because dense mode is flooding and pruning method. What is the flooding and pruning method? All the time the multicast packet will be sent to all. But when you use dense mode, the multicast address will go only to those leaves that has got a receiver. It won't go to leaf 2 because there is no receiver. So spats mode is good because through RP it knows where the receivers are. In dense mode there is no rendezvous point, there is no meeting point, so every packet will go to all. Dense mode is not a scalable multicast solution. Spats mode is what we need, so that's why we enable spats mode on all the ports. You see, IPPIM spats mode. not only on the newly connected interface, even on these old interfaces which already exist now. You remember in the previous lab we have done OSPF on this links. All the links we are enabling PIM spares mode along with the RP address. Yep. So only on the spine we will give these two lines, Anycast RP. On the leaf we will repeat this IP PIM RP address on the leaves. On the leaves, if you go on the leaves also we enable PIM, and then we put this command, we put the IP address of the RP. We tell all the leaf that these two guys are the RPs. But for these two guys, what address we have given? 0.100. 192.168.0.100. So that's what the configuration that you see here. IP PIM RP address. See, I'm doing this on leaf 1. On leaf 1, I've enabled the feature called PIM. Globally, I'm enabling multicast feature. And then I go under all the interface as usual as I did in the spine. Here also I say IP PIM spares mode. And then I put this command IP PIM RP address, the rendezvous point address. That's all. When you repeat this, we finish our multicasting, and I should see this PIM neighbor. I should see this 4 leaves as the PIM neighbor. Shall we do this? Let's finish this, okay, today. All right. I'm going to.
Question, sir.
Yeah, question, please.
Okay. For this command IP PIM Anycast. Anycast RP means.
Anycast means nearest RP. Anycast. IP PIM nearest. IP PIM. Anycast means, the address can be duplicated. It means both .6 and .7, both the spines have got same IP address, right? They got same IP address. And for leaf 1, if spine 1 is nearest, it will use spine 1. If spine 2 is nearest, it will use spine 2. If both are nearest, it will use both, but the address is same. That is what called as Anycast. Anycast means 1 to the closest. That's the meaning of it.
It will calculate based on the cost or.
Very correct. OSPF cost. OSPF cost. Okay. But OSPF cost is going to be same, no? Because you're connecting Anycast RP on the spine. So it will be equal cost multipathing.
In that case, what will take?
It will use both. That's what we want. We want both the spine to be RP, so that equal cost multipathing will happen. So it will use both. That's the reason why we are.
IP PIM RP address.
That is to define rendezvous point. Any device can be a rendezvous point, but in our example, if you make spine as a rendezvous point, that will be more correct. What is rendezvous point? Meeting point. Where will we meet? Somewhere in the middle, right? So I cannot make this leaf as a rendezvous point. You can make, but it won't be good. It won't be good. Spines are the one which I can make rendezvous point. So I make these two as a rendezvous point, and I go to all these leaf and say the address of these RPs is a rendezvous point. That's what you see here. You see, this is the address of who? Of spine. Yeah? On spine only we configure this. Yes or no? You see, it's mentioned here, spine 1. You configure this. And then we go to all the leaf, and we don't have any leaf with that IP address. But spine has got that IP address on loop 1, loopback 1. But on leaf you don't have the IP address, but we still say that you can find RP on this address, meaning we are saying RP is spine. RP is spine. This is pingable, right? Because you are running OSPF on spine. So all the leaf can ping that address. What is the 0.0.0.0? It simply means area 0. In OSP, in Nexus, that is a format. Right? Shall we do this now?
And one more question.
Mm-hmm.
We are enabling globally PIM on all the.
Not globally, on all the physical interfaces we need to enable.
All the physical interface.
Okay.
So already this multicast is already by default it is enabled, right? Because
no, we need to put this command feature PIM to enable multicasting.
Okay, but by default it's not enabled multicast because
no, it is not enabled.
Multicast, right?
What?
hello packets and everything is going through
No. That multicast is different from this multicast. That multicast is having scope of only one hop. That multicast packet of your OSPF won't pass through the router. It is going to the router. It is not passing through. It's just to the router. Only one hop. See, in OSPF, when leaf won't send an update, it will be sent to this port. That's all. Is it passing through? No. It goes to spine, and spine will digest it, and spine will forward it. It is not passing through. Update will go to one router, and that router will synchronize its link state database, and then it will forward it. The packets are not delivered straight to leaf 1. It goes and takes one stop and then redistributed to another stop. That is not the multicast that we are dealing with now. The multicast that we are dealing is the multicast traffic that needs to go straight and deliver here. Whereas your OSPF's updates are delivered to only one hop. For that, you don't need to enable multicasting. To deliver to one hop, we don't need to enable multicasting. Simply one multicast address is enough to deliver the packet. You remember in layer 3 switches, we put IP routing. Only then the routing will happen on the switch. Only then packet will get routed and pass through. For passing through, I need to put IP routing. But to ping the switch, do you need IP routing? Just you are going to ping the switch, not someone beyond the switch. You don't need IP routing command. You just take one switch, put an IP address on the VLAN 1 interface, and try to ping from here. You will ping. But if you try to ping another network, which is in VLAN 2, it is not possible unless you type the command IP routing. Only then from one domain it will go. Likewise, we enable PIM so that routing can pass through. Yep. Alright. Hold on. You see, now we're going to go to spine and say admin C1S CO 1 2 3 4 5. And I'm going to configure feature PIM. First I need to enable PIM. Feature PIM. Done. And what is next is, don't worry about this message. It simply says, you need a license. It is already the necessary license. Admin and C1SCO 1 2 3 4 5. C1SCO 1 2 3 4 5. Here also I'm going to say feature PIM. Done. Actually this need to be put on all the devices. We need to put this on all devices, even including leaf. But before that, let us finish the spine thing. On spine I'm going to say I need a loopback interface. Currently show IP interface brief. I don't have loopback 1 interface. I'm going to create one now so that I can use that as the RP, rendezvous point.